Welcome to this new video dedicated to the foundations of electronic music. Today, we're diving into the world of MIDI. If we break down the acronym MIDI, which stands for Musical Instrument Digital Interface, we can focus on the word interface, a system that enables the connection between two or more units to exchange information. A simple example of an interface between devices is a USB port. In the context of MIDI, there are two essential aspects to understand. One, physical aspect. This is what allows information to reach its destination. It's the transmission medium, which can be a cable, Wi-Fi, or Bluetooth. Hacker 2, logical aspect. This is the common language used for communication. For two devices to interface with one another, they must speak the same language. Both the physical and logical aspects must be present and functioning for the interface to work properly. A clear example is the human-machine interface. A piece of software acts as the interface between the human and the computer. Even between two people, we can talk about an interface. To communicate, they must be in the same place, physical, and speak the same language, logical. The digital, in MIDI digital, means that the information is expressed through numbers. There are two main categories of audio media. Analog, like vinyl, where the sound wave is physically etched into the grooves. Digital, like CDs, where the sound is represented through numerical encoding, a finite sequence of numbers. The musical instrument in MIDI. This refers to electronic musical instruments, where the sound is generated not by mechanical parts in motion, but solely through electrical current. The birth of the analog synthesizer, 1964. The term analog refers to sound generated via electrical current, without digital encoding. Today, we're used to software synthesizers that emulate analog synthesizers through digital coding, reproducing waveforms nearly identical to those generated by the original circuits. The pioneers of this sonic revolution were Robert Moog and Don Buchla. Working independently, they developed the first modular synthesizers. Their goal wasn't to replicate traditional instruments, but to invent a new way of sound creation based entirely on the manipulation of electrical current. Moog, working in New York, shaped the East Coast approach. Buchla, working in San Francisco, defined the West Coast approach. Modular synths and controllers. Early synthesizers were modular, composed of separate modules, oscillators, filters, envelopes, etc., connected by patch cables. A key component was the controller, like a keyboard or sequencer, which had to be connected separately. The need for standardization. Enter MIDI. By the early 1980s, musicians needed a standard communication protocol to connect controllers and synthesizers from different brands. This gave birth to the MIDI protocol, a universal interface that revolutionized how electronic musical instruments communicated with one another. The Moog breakthrough. Robert Moog had a brilliant idea: create a demo to promote the sound of his synthesizer. When these sounds began to appear on records, the synthesizer was finally recognized as a real musical instrument. The breakthrough came with the album Switched on Bach, 1968, 12 pieces by Johann Sebastian Bach, arranged and recorded entirely on a Moog synthesizer by Walter Carlos and produced by Rachel Elkind. The album became the best-selling classical record of its time and launched a wave of interest known as Moogmania. Carlos later transitioned and became Wendy Carlos, continuing a brilliant musical career. Making synths portable, the Minimoog. Despite their success, modular synthesizers were bulky, fragile, and expensive, far from ideal for live use. To solve this, Bill Hemsath, a Moog engineer, developed a compact and integrated synthesizer, the Minimoog. Unlike modular systems, the Minimoog had a built-in keyboard and hardwired modules, ready to use right out of the box. It was a commercial success and a game-changer for live performance. ARP, EMS, and European innovation. Meanwhile, ARP Instruments, founded by Alan R. Perlman, created the ARP 2500, a modular synthesizer that used a matrix system instead of patch cables, avoiding the infamous spaghetti effect. In 1972, ARP responded to the Minimoog with the ARP Odyssey, a compact performance-ready synthesizer. In the UK, EMS, Electronic Music Studios, founded by composer Peter Zinoviev, developed the VCS-3 in 1969. It was a compact modular synthesizer with a 16 by 16 patch matrix using metal pins, an elegant solution for routing signals. Synths in rock, Lucky's lead. Moog synthesizers were also being used in pop and rock. A legendary moment occurred with the song Lucky Man by Emerson, Lake and Palmer. Keith Emerson used a Moog modular synth for the famous final solo. That distinctive sound became iconic and was nicknamed Lucky's lead, one of the first true synth solos in rock history. MIDI was born from all of this innovation, a revolutionary interface that enabled electronic instruments to speak a common language, no matter the brand. Today, it's the invisible backbone of every DAW, plugin, and live electronic performance. Thanks for watching. If you found this helpful, drop a like, hit that subscribe button, and ring the bell so you don't miss what's coming next. Got questions or thoughts? Let me know in the comments. And if you'd like to support the channel, check out the links in the description.